Hello student. As in my previous video, you have seen the principle of superposition I have explained. That is, from the two different sources, the light wave that is traveling and reaching at a point P, and they superimpose. The conditions of the equation was that y resultant equals to y1 plus y2, the vector sum of the two displacement of these waves. Here I have shown you that if the waves are in the same phase, then they will give you the resultant wave in this form. And here I have given the two more example over here so that you can understand. Okay, first wave is this way and second wave is this one. Right? So you just see if their amplitudes are different, so thereafter the superposition you will get the resultant wave of this type. But when they are in the opposite phase, one wave is coming this way and another wave is coming this way. It means here you can see they are in the opposite phase. They are in the opposite phase. So in this case, if the A means amplitude of these two waves are the same, then it means A1, both A1 or both A2 or both is A, then the resultant wave will be of the with the displacement, that is it becomes 0 flat. The amplitude becomes 0 flat. This is the resultant wave. Okay. Now we will proceed. In this case, since the wave frequency, that is the same, velocity same, and the other factors are also same, k and lambda. In this case, when they are propagating this way, then there is the phase difference between them. So let us find out how we will get the phase difference between these two waves. Suppose if x2 is greater than x1, then the phase difference that you will get by this way, because this factor is the called phase. This is the phase of the wave. So the phase difference phi is equals to, you can subtract these two, omega t minus kx2, then minus omega t minus kx1. On subtracting, these two factors will be cancelled out. So what we will get, that is, here we can get like that, k delta phi is equals to x2 minus x1, or in this way x1 minus x2, that also you can write this x2 minus x1, or if you subtracting from this, to that you will get, or if x1 is greater, then you will get, if x1 is greater than x2, then phi is equals to, and k is a constant over here, and then here also you will get k x1 minus x2. These two you will get. This is the phase difference. So you can write phi, this is phase difference between these two, is equals to k into delta x. That you can write. That is, delta x is called the path difference. Delta is called the path difference, where delta x is equals to, is called the path difference. If this is the phi 1, this is the phi 2, the difference of that is the delta phi. That way also you can write. sin omega t like this. So you can write delta phi is equals to this. The phase difference is equals to k delta x. Now if we will put the value of k, then we will get phi is equals to 2 pi by lambda into delta x, because you know where we know that k is equals to 2 pi by lambda. So this is the another form of the phase difference. Now like that we can get the angle between these two. If you wish, one is going this way, and that is the amplitude, and this another is this way, and the resultant between them, the total angle that was between them, the phase, they are differing by phase phi. So resultant you will get here only, and this is the whole angle that was the phi, and this is A2, that amplitude A2, this is A1. The resultant, if that goes in the direction of the theta, this is the A resultant. Amplitude resultant is this. So to get that theta, you can use that tan theta. Tan theta is equals to A2 sin phi upon A1 plus A2 cos phi. This way you can get the value of theta also. This way you can get the value of theta. And the resultant amplitude, if you want to get the resultant amplitude by the vector, resultant of the two vectors, the parallelogram method, that way you can get this resultant amplitude will be resultant amplitude that will be A resultant, that you know according to the vector sum rule, that is A1 square plus A2 square plus 2 V1 A2 cos phi. This way you can get the resultant amplitude of these two waves. Or in short, you can write y is equals to AR sin omega t plus kx phi, like that also you can write. So this is the resultant. Now if the coherent sources will be there, then omega will remain same. So for that, this equation you will get for the resultant amplitude also. Now let us see the intensity. What will be the intensity? Intensity of the wave, what it should be? The intensity, it is found that intensity is equals to 2 pi f square a square rho into v. This is the intensity of the resultant wave. Now what is there? Let us see here. The rho comma velocity, these two the same for the same medium, means these two will be the velocity, the speed of the wave, and the density of the wave will remain same if the medium is the same. And secondary, it is already said कि omega and frequency both will be the same because omega is equals to 2 pi f, and for the coherent source it will also be the same. For coherent source it will also be same. It will also be same. So the constant factors are f, that rho, v, and 2 pi is already constant. So what is left? Only A, amplitude is left. So we can say the intensity is directly proportional to the A square. This is the intensity is directly proportional to the A square, and this proportion sign will be replaced. So constant K is there, K A square or amplitude, that formula you can use, and A square or A is equals to I upon K, and under root. You will put the under root, that is under root I and under root K, that you can use. So the two other formula, that is B or C, where K is a constant, proportionality constant. And now as the resultant of the intensity we want, so we will use that. The resultant amplitude we will use, that formula we can use. So resultant amplitude, what you have seen, that was here I have already written. So from that we will derive A resultant is equals to A1 square plus A2 square plus 2 A1 A2 cos phi. Now A1 square, so that from this equation you can get I upon K, so resultant intensity IR upon K, here A1 again square, so it becomes I1 upon K, then it is I2 upon K, and it is 2 A1 A2. So A1 for this is becoming under root, under root I1 upon under root K into, here again it will be under root I2 upon under root K into cos phi, that will be into the cos phi. So you just see कि this under root K and under root K, it will be K, here it is K, here it is K. So entire expression will multiply by K. So all this K will be cancelled out because multiplication of these two will be K. So finally the intensity IR is equals to I1 plus I2 plus 2 I1 I2 into cos phi. This way we will calculate the intensity of the resultant wave. So for the superimposition cases, if the waves are different, they originated from the one source and they are traveling the different they originate from a same source, that is why their frequency same, but from that it is traveling the different distances, therefore their path differences, the path differences there, and that is why there is a phase difference only for that reason, because this path length is different. That is why there is a phase difference between when they are meeting at this point. So in that case we will calculate the phase difference. We will calculate the phase difference, and phase difference can be calculated this way. And this is the main equation for the phase difference, which is the path difference 2 pi upon lambda. Lambda will remain same for both the waves because they are originated from the same source, so coherent sources. So which is already said कि lambda will be same because omega frequency same, so wavelength same, that all will be same. And only if the path difference is this or the phase difference this, so that phase difference will always remain same throughout that if the coherent sources are there. If the different from different sources you are generating these two waves, then if omega is different, then this will not remain always constant. This phase difference will always not remain constant. Since it should remain constant, that is why we are using the same frequency or same wavelength. And so omega will remain same, so this phase difference will always remain constant. And the resultant amplitude in that case will be this much. The maximum or the resultant, the maximum case, so we will get max, or many cases we will get from the different values of the cos phi, that we will discuss in the case of the interference. Next we are going to discuss that case of the interference. And interference is one of the keys of the superposition only. The condition, with the condition when there is a no phase difference or a constant phase difference, the superposition is taking place, but the phase difference, this phase difference is either the constant or the zero. That case, that phenomena is called the interference, which I will going to describe you and explain also. And in that case, this is the resultant amplitude of the wave at that point. And what will be the intensity at that case? After the superposition, the intensity is, we are getting this formula, and in this f is the frequency, which remains same because omega is the same, so f will the constant. For the same medium, density will be also the same, v velocity will also remain same. So this one, and 2 pi all are the constant factors. The only variable is a, so we can write I is directly proportional to the a square. So I is equals to, a constant has come, a square, a is equals to under root I upon under root k, and we will put that value in this equation. We will get like that. The resultant intensity will be equal to I1 plus I2 plus 2 I1. No, here it will be under, within the under root. This will be, because both are the under root, so it will be the under root I1 I2 cos phi. So this is our final equation for the intensity. Now we will put the different cases for the max or mini, or for the other cases we will put the different value of phi, as the phase difference will be there. Accordingly we will get the intensity. So we will discuss all this in the next topic, interference of light. Okay.